I invite you to listen to a presentation on performance analysis of solutions that allow you to get object-oriented structure from source code. The talk will discuss software testing, including static software analysis. This will be followed by a presentation of the purpose of the analysis, the test environment built and the results. On the subject of software testing, ISTQB should undoubtedly be mentioned. This is the most important standard in this field, at the same time indicating how important software testing is. In addition to this, testing during the software production process is widely accepted. In this process, too, there are many solutions. However, the most popular are tools integrated with IDEs. These tools are based on one of two ways of analysis: dynamic, where the executable form of the application is analyzed, and static, where the code is analyzed. This presentation will discuss static analysis. As already mentioned, static analysis involves analyzing the source code directly. This has a number of advantages, including that the code can be analyzed on any machine, which is sometimes impossible with static analysis, such as when trying to analyze applications for embedded systems. The main disadvantage of this approach is the large amount of data to analyze. The Microsoft .NET development platform was chosen for comparison because of its ECMA 355 standardization. It was decided to analyze managed code because part of the analysis in such code was performed by the compiler. Solutions of this type are used in many commercial tools and scientific research. An important advantage is that it is one and the same code that can be compiled from different programming languages. The purpose of this presentation is to compare selected solutions for extracting object structure from intermediate code, bytecode, for subsequent static analysis. Obtaining the object structure is the first stage in the static analysis of the source code, so the choice of the appropriate solution for obtaining the object structure from the intermediate code determines the duration of the entire static analysis process. A comparison will be made between Microsoft Reflection and MonoCecil. Both solutions are very similar from the point of view of a programmer implementing tools using the mentioned libraries. In order to demonstrate other differences, namely speed of operation and resource usage, a model has been built. The figure shows a data model using an entity relationship diagram in Barker notation. The basic entity with object-oriented programming is type. A type is classes, interfaces, structures, etc., as determined by the kind of type dictionary entity. A type contains access modifier and modifier modifiers, fields, methods, etc. Formally, a type is expressed by a tuple T. The T-tuple details the model. The model was developed to examine the code of programs in terms of implementation of design patterns and to verify the correctness of multi-threaded applications. Based on this model, a comparison of Microsoft Reflection and MonoCecil was conducted. The results of the comparison are as follows. The comparison was performed on 3 different sets of binaries. Table 1 shows the average execution time and standard deviation for the times from the entire series of repetitions. Each series contains 100 source code acquisitions, as well as the percentage difference between the tested methods. The times are presented in seconds. For set number 1 and number 3, the time gain in favor of MonoCecil is noticeable. The results for set number 2 are comparable with each other. However, it is puzzling that the difference is so small. In order to get an answer to this, it is necessary to analyze table number 2 as well. The low value of the standard deviation indicates the absence of random events that could adversely affect the whole process. Table 2 shows a numerical summary of the number of types found, the remaining components and the maximum RAM usage. After analyzing the data in table 2 for set number 3, one can see a higher number of found types for MonoCecil. This is due to the assumptions of this library, which introduce additional decomposition into modules. A feature of reflection is the retrieval of all components of the type under study, including those inherited from parent classes, while MonoCecil retrieves only components present only in the type under study. The others are accessible through the base type property of the type under study. Very important are the differences that result from analyzing the results for set 2 and set 3. First of all, the significantly higher number of types found by MonoCecil should be explained. Finding more types is not only due to the previously mentioned additional decomposition into modules. The difference is due to problems during the reflection mechanism. The reflection mechanism was unable to analyze sets that used types outside the tested set, so-called blind types. Despite many attempts, the problem remained unresolved. Summarizing the research carried out, the best results came from the monoccile solution. Details of these results can be found in the paper. This solution gives very promising results and will be used for further research on software analysis in terms of implementation of design patterns. In parallel, research will be conducted on concurrency in data processing mapping object-oriented structure. Thank you for your attention.